Hello everyone and welcome to our channel. Today we are going to see the differences between Java and other programming languages, and these are the contents we are going to see today. Today we are going to see majorly the four differences between the Java and other programming languages, and in our next video we will see the remaining differences. See the first difference. We are going to see how a language is said to be a platform dependent and platform independent, and when a language is said to be a static or when a language is said to be a dynamic programming language, and whether a language requires the preprocessor or not. We are going to check it out, and we are going to know the importance of pointers and whether the Java supports the pointers or not. Now let's see each of them in detail. Now the first one is whether a language is platform dependent or independent. Now see the first one, Java is a platform independent language. It means what? Let me show you the definition over here. See, Java allows its applications to run over multiple machines, which means what? Any programming language that allows its applications to run over multiple machines, whether it can be of Linux, Windows, or any platform. If it allows to run over multiple platforms, then we can say that that programming language is platform independent. So Java is platform independent, which means if you built an application, Java application in Windows, it can able to run on Linux, it can able to run on various versions of Windows, and similarly it can able to run on Unix, and it can able to run on Mac, anything. So we can able to say that Java is a platform independent language. Now see here an example of platform dependency. A C program, right, that was developed in Windows 62-bit Windows will not execute in Linux or other platforms. You may take other platforms like Windows 64 or Linux, Unix, Mac, anything except the same platform, right? Whatever the platform you use it for developing, if you use the same platform, it will execute. Other than this, no other platforms will support that code. Okay, why? Because there's a change in representations, right? OS representations will vary from one OS to another OS. That's why we can say that C is a platform dependent language. Okay, now let's see how platform dependency and platform independency can be achieved. Okay, now let's see here. The platform dependency means, see the dependency over here, whatever the C program you take, right, when you compile the C program, you will get an executable file. So this is the drawback of it. The executable file will contain the OS representations also, means what is the compiler that we are using, what is the machine OS we are using, and any infrastructure related things the executable file will hold. Which means what? The executable file is dependent on platform, right? It is dependent on the machine. For example, see, if I compile my code over Windows 32-bit, so the executable file will be generated as per the Windows 32-bit. So when I try to execute over the Linux, Mac, or any Windows 64, it won't execute. Why? Because here the representations are of one type and here the representations of second type. So there's a difference in the representations. That's why whatever the executable file you generated over here, it won't execute here. Okay, but if you use the same platform, right, whatever the developing platform you have taken, if you are trying to execute over the same platform, it can able to execute. Okay, so that is what we call it as platform dependency. Means it will depend on the platform. It will run over a simple platform only. Whatever the platform you use it for developing, it will execute in those platforms only. Other than this, no other platforms will be supported. Okay, now let's see an opposite of it, which is nothing but the platform independency. See, the Java is a platform independent language, right? See how it is going to be happen. See, whatever the Java code you taken here, when you compile it over a Windows 32-bit, you will get a .class file, right? That is what we call it as a bytecode. Okay, now this is the major advantage of it. What is a bytecode means? It is a neutral representation of this compiled code. Okay, it is not executable file, it is not dependent on the machine, it is just a neutral representation of whatever the Java statement that we written here, those will be compiled. A neutral representation of bytecode will be represented in the .class file. Now what we are going to do means, for example, if I want to execute in a Linux, a Mac, or Windows 64 or any other system, It is developed over Windows 32, right? Other than this, any other platform I'm going to use, it going to execute. Why? Because see, internally we are going to take a JVM to execute our Java code, right? See, inside the JVM we are having the converters and then execution, the Java runtime environment, right? Now see here, whatever the .class file you have taken, when you have given to this converter, it will generate the native code. Means, for example, if I'm using the Linux, it will generate the Linux representations. For example, if I'm using the Mac, whatever the neutral code it has taken, the converter will generate the Mac code. For example, if I have taken the neutral code and given to the Windows 64-bit operating system, then it will generate, the converter will generate the Windows 64 representations. So see here, due to this JVM, due to these converters, what will happen means, whatever the neutral code that you taken, that will internally converted into the required, right? Required the machine code. So that's why see, we can able to say that JVM is machine dependent, okay? Which means JVM is platform dependent. For Linux, you need to use the Linux JVM only. For Mac, you need to use Mac JVM only. For Windows, you need to use Windows JVM only. Why? Because it takes the neutral code as input and it generates the machine code, the machine specific code as output. That's why JVM is a machine dependent or platform dependent, whereas Java itself, the complete Java itself is platform independent. See, whatever the code that you developed using Windows 64-bit, it can able to run successfully on any platform you can take due to this JVM concept. Okay. Now similarly, see, if you take the same platform, no problem, it will execute finely. And see, even though you change any platform, JVM will convert internally to that required format and can execute it. Okay. So that is what we can call it as platform independency in Java. Now let's see the second thing. What is a static and the dynamic language? See, a language is said to be a static if the memory allocation for the primitive data types is done at the compilation time. See, in case of C and C++, the memory would be allocated at the compilation time itself. Okay. But when you compare to the Java and Python, these are completely object oriented, right? Now see, the memory allocation for the primitive data types that we see are executed at the runtime, means the memory allocation will be provided at runtime. That's why these Java and Python programming languages are known as the dynamic programming languages. Okay. And the C and C++ are called it as the static programming languages. Now let's see the next difference. See, the requirement of the preprocessor, right? See, we know that in C or C++ we can able to see the header files, right? Hash include stdio, standard input output header files, standard library header files, math header files, or some file header files in order to do some predefined operation, right? For example, I need to use some predefined methods, a printf, scanf, everything. I need to import the standard input output, right? What is the header files do? These header files will be included, right? We need to include the header files in our code, and we can use the methods available in this header file, which is nothing but these are just like software that is available at the location of our installation, right? When we install the C program into our system, right? C software into our system, these header files will be included, right? These header files will be installed. Now what we want to do, whenever I write a C program, .c program, I need to include those header files and I can use them in my code, right? Now what is happening means, see, now in order to load the content into these header files, the compiler will take the responsibility and it loads at the compilation phase itself. See, at compilation phase itself, the preprocessor, right, will recognize these statements, means these header file statements, and it searches for the header files and simply it loads them into the memory. So what happening here, at compilation phase itself, we are allocating the memory. So that is called as the static loading, right? Now a quite opposite for it is the dynamic loading. See, in Java, whatever you want, the predefined things, those will be available in form of the packages, right? The packages like java.io, java.util, SQL, servlets, and anything, whatever you need, the predefined things, you can take in form of the packages. You just need to import the packages, right? Using the import keyword, you need to import those packages and simply you can use the code present in it, like the classes, interfaces, or anything. Now see what is happening. See over here. At compilation phase, what it will done, compiler will recognize the import statements and it checks whether the particular package is available or not. That's it. It doesn't load at the compilation phase. Okay. Now see, when the package is not available, it raises the error. When the package is available, it's fine, and the JVM will take the responsibility to load the package's content into memory at runtime. Okay, it will be loading dynamically at runtime. The memory allocation would be done, so that's why we can call it as a dynamic loading. In C, header files concept would be there, so you need to use the static loading. Whereas observe here, the dynamic loading will be done, right? So what happens? Preprocessor will be present here. Why? Because the task of the preprocessor is to observe these statements and load the content. Whereas at the compilation phase in Java, there is no need to load anything, right? The JVM will take the responsibility to load it. So that's why we can go for dynamic loading here, and here is a static loading. So preprocessor would be present. In this case, there is no preprocessor for Java. Okay. Now see, observe here the pointers concept. You know the pointers, right? What the pointers do? For example, I have taken a variable of integer type A and it is holding some data 10. Now similarly, what I done? I have taken a pointer P, right? The pointer P is what it is doing means it's a variable only. It holds the address of another variable. For example, the address of this memory location is, for example, 1000. So it holds this address 1000 into this variable. So that's why we can call it the P as a pointer variable, right? We can create single pointer, double pointer, triple, right? Multiple pointers, single pointer. We can create a double pointers. We can create triple pointers, right? We can create it, right? The pointers is nothing but the direct accessing to the memory, right? So this would be a problem for us, right? If you are giving the direct access to the memory, so it is a security threat would be there. So that's why the Java won't support the pointers concept, right? Security is the major criteria for the Java. See, pointer is a variable that stores the address of another variable, and pointer variables require the static memory allocation, whereas in Java we will do the dynamic only, right? Dynamic memory allocation. And pointers will provide less security. As I told you, we are going to access the memory directly means we are compromising with security, right? So Java will not do that. So Java will not support the pointers. And you know that multiple pointers, right? Multi-level pointers is a confusion concept. See, let me tell you, there's a memory over here. A pointer is referring to it. This is a single pointer, right? Now similarly, a double pointer is there means it refers to the memory of another pointer. Like, for example, there's a triple pointer over there means it refers to the memory of a double pointer. Like this, if you are going in depth, right? If you go in depth, if you want to access some data over here in the memory location, it would be a confusion concept. Okay, so that's why there will be no chance of confusion and no chance of less security in the Java. That's why Java won't compromise with the security and it won't provide the pointers. See, Java won't support the pointers in order to become highly secured and simple means without any confusions. So there is no concept of the pointers in Java. You can see the pointers concept in C, right? So keep a note of it. There is no concept of pointers in Java. Yes, and these are all the key differences between the Java and other programming languages, and we will see the remaining differences in our next video. Keep watching us. Please do like and subscribe to our channel. Thanks for watching.